Today we are going to talk about cylinders, and the way that we are going to look at cylinders is we're going to start looking at lateral area and total area. Now this concept is pretty similar to what we were discussing the other day with prisms. For cylinders, basically a cylinder is a prism that has a circular base. So we're still going to use some similar formulas that we did with prisms for lateral area and total area. The only difference here is that the perimeter of our base is the circumference. So if we think perimeter equation, if we let P stand for perimeter, well, that's going to be equal to our circumference, which, if you recall, is diameter times pi, or 2 pi times radius. So to find the perimeter of our base, you have to find the circumference of whatever that circle is. Now, this little cutout here, let's say that this figure on the left is going to represent the lateral area. The lateral area that we could think of is going to be all of like the side of this cylinder. Maybe think of like a soup can or something like that, where your lateral area would be the label that you could rip off the can. So it's just going to be that outer part, the lateral faces, but it is a rectangle that kind of wraps around your whole surface there. Now, let's write that out. The lateral area is a rectangle with, it's got a length which is equal to P, which we said was going to be the circumference. Oop, spelled that wrong. And a width, which is going to be the height. And that's the height of the cylinder. So we've got our perimeter, which is the circumference, and then our height, which is going to be the height of, or our width, which is the height of the cylinder. So if you think lateral area, you're just doing like a rectangle. It would be base times height, but in this case, it's going to be the circumference times the height. So let's write that out as a formula. We've got lateral area is equal to perimeter times height. P is circumference and then our total area, similar to what we saw with prisms, is going to be our lateral area. So think like total area here. This is my rectangle that we have there. So I'll quickly shade that in. I'll do that a little bit better here in a minute. So there's my rectangle, but then I also have to add in 2 areas of the bases. And for a cylinder, our base is a circle. So you're really just finding the area of these 2 different circles here. So if this is one circle here, and this is the next circle here, that's going to be our total area. Let's look at an actual example of this. So we're going to practice, we're going to draw a cylinder here. So I'll kind of walk you through it. So example, to draw a cylinder, you're going to draw like a little oval up here. So mine cheats a little bit because it gets to finish it. And then I'm just going to drop 2 lines going down the side, kind of like so, of equal length. And then I'm going to draw a second oval like so. Oh, that's bad. Oval. Like so. So notice that the dotted part would be like the behind of there. Now let's label it. I'm going to say that this edge is 15 centimeters, and then I've got a radius here of the upper circle of 3 centimeters. So I'm going to label these parts out. And how I'm going to label it is I'm going to say, all right, where is the base? And my base is this circle here with a radius of 3. So if my radius is equal to 3 centimeters, that means my diameter is equal to 6 centimeters. Now, after you find what the base is, or identify what the base is, you have to determine the perimeter. And do the perimeter of the base, that is P, which is circumference, which is diameter times pi. So the perimeter of my base is 6 pi centimeters. So that's enough information to do lateral area. Because our lateral area is equal to perimeter times height. So LA is equal to, that's 6 pi times 15. The height of our figure here is 15. So my lateral area is equal to 90 pi centimeters squared. And I'm going to leave this in terms of pi. If it wanted an approximate total or lateral area, then you would multiply by 3.14. But here I want the exact, so I'm going to leave that in terms of pi. Now, to figure out total area, I need to come back and figure out what is the area of the base. And to do area of a base, it's just area of a circle. So area is equal to pi r squared. So my area is pi times 3 squared. So my area is 9 pi centimeters. Now that's enough to go off of to determine my total area. Because total area is equal to lateral area plus 2 areas of the base. So TA is equal to, that's 90 pi plus 2 times 9 pi, which is 18 pi. So my total area turns out to be 108 pi centimeters squared. So this is a basic introduction to cylinders with lateral area and total area. We will discuss this more in class as far as breaking it down and trying to identify what's your lateral area, what two circles or figures within are your bases. Make sure you hit that like and subscribe button, and as always,